Something happens to crappie every summer, and most anglers have been explaining it wrong for decades. The fish do not disappear. They do not stop feeding. They shift to a very specific depth, and they hold there with a consistency that would seem almost mechanical if you understood what was driving it. The problem is not that crappie become unpredictable in July and August. The problem is that anglers are looking at the wrong depth based on an assumption that was already being questioned by serious freshwater anglers 100 years ago. That assumption, that crappie locate around visible structure, and that finding the brush pile means finding the fish, is not wrong in every season. In summer, it is precisely the assumption that leaves good anglers standing at a productive-looking dock with nothing to show for 3 hours of careful work. The fish are not gone. They are somewhere else in the water column. And the reason they are there is not random. In late spring, as surface temperatures climb and the sun begins its long summer arc, something invisible happens in every body of still or slow-moving water, deep enough to stratify. The water column separates into layers. Warm water floats above colder water. Between them forms a zone where temperature drops sharply within just a few feet. This boundary is what biologists call the thermocline, but it carries a second characteristic that matters more to crappie than temperature alone. It marks the lower boundary of where dissolved oxygen remains adequate for active feeding fish. Below the thermocline, oxygen falls to the point where game fish cannot sustain feeding. Above it, summer heat pushes water past the range where crappie metabolize efficiently. The thermocline band itself, sometimes only 2 or 3 feet thick, is where temperature is cool enough, oxygen is sufficient, and bait fish concentrate. Crappie, every summer, follow that band with a precision that has nothing to do with the dock or brush pile the angler is casting toward. Crappie are not choosing the thermocline out of preference. They are responding to physiological pressures that leave them no viable alternative. As cold-blooded animals, crappie regulate body temperature through surrounding water. Their metabolic efficiency, ability to digest food, respond to prey, sustain position, is directly tied to water temperature. In the warmest surface layers, a crappie's metabolism accelerates past the point of efficiency. The fish burns energy faster than feeding can replace it. In the cold, oxygen-depleted water below the thermocline, metabolism drops to the point where active feeding becomes unsustainable. At the thermocline boundary, where temperature cools and oxygen remains adequate, crappie find the precise conditions their biology requires. This is behavioral thermoregulation, the same mechanism that positions crappie the same way in the same depth band on similar lakes across the American South and Midwest every July and August. Regardless of what structure happens to sit at that depth, bank fishermen working southern reservoirs and Midwest farm ponds in the early 20th century did not have the language of thermoclines or dissolved oxygen, but they had something that produced the same practical result: close observation of a specific and repeatable summer pattern. On lakes they knew well, the productive crappie depth in late June was almost never the same as in late April. A brush pile that held fish at 8 feet in May held almost nothing at 8 feet in July. But that same pile, extended to 15 feet, would produce in July, not because the deeper section was structurally better, but because that depth intersected where the fish had to be. Old bank fishermen noticed this without explaining the mechanism. They described it simply: the fish moved down. But the better among them developed a specific method for locating the precise productive depth on each body of water, without any equipment beyond what they already carried. That method has been absent from fishing conversation for at least 60 years. The method required no explanation among those who used it. A live minnow, small, healthy, not already stressed, was placed on a light hook and bill lowered slowly, 1 foot at a time, with a pause at each depth. The angler watched the minnow's behavior. In the warm upper column, the minnow swam freely in a wide arc, showing no distress. As it entered the transition zone, where oxygen thinned and temperature began to drop, its behavior changed. The swimming became labored. The arc contracted. Another foot deeper, the minnow would begin to turn sideways. Left below that point for a minute, it would die. The depth where the minnow first showed distress was the bottom edge of the productive zone, 1 to 2 feet above that point, where the minnow still swam freely in cooler water, was where crappie suspended, no electronics, no depth finder, a minnow on a line, read by someone who understood what its behavior was reporting about the water column below. This is where the structure assumption collapses, and understanding why it collapses changes every summer fishing decision afterward. Structure, a brush pile, a dock piling, a timber edge, a submerged point, is not a fish location, it is a reference point. Crappie use structure as ambush cover, but only when it intersects the depth where their physiological requirements are already met. In spring, when temperatures are relatively uniform and oxygen is plentiful at every depth, crappie distribute around structure across a wide range. The angler casting at 8 feet or 12 feet in April finds fish at both because the thermocline has not yet formed. In July, the thermocline is established. The crappie that covered the full face of a brush pile in April are now suspended within a 2 or 3 foot band at whatever depth the thermocline sits, 14 feet on a clear lake, 9 feet on a murky one. The angler casting to the dock at 6 feet is fishing real structure. They are simply not fishing where the fish are. The structure did not fail. The depth assumption failed. The thermocline does not sit at a fixed depth around the clock. During early morning, before the sun has heated the surface layer, the temperature differential between upper and lower water is at its smallest. The thermocline sits somewhat deeper than it will by afternoon and is less sharply defined. Crappie in early morning may be found across a broader range of depths, still in the cooler portion of the column, but not yet compressed into the narrow band they occupy by midday. As the surface heats through mid-morning, the differential increases and the thermocline sharpens and rises slightly. By early afternoon on a clear summer day, the thermocline is at its most compressed and precisely defined. Crappie at that hour are holding in the tightest band of the day. The angler fishing the same depth that produced in early morning may find nothing by noon, not because the fish left the area, but because the thermocline shifted and the fish moved with it. This is not unpredictable behavior. It is predictable movement driven by a measurable physical change in the water. Understanding the thermocline as the primary summer positioning mechanism changes how the first 10 minutes on the water should be spent. The first question is not where is the structure, it is where is the thermocline today. On clear lakes, the thermocline often sits between 15 and bh 25 feet. On murky or stained water, it may be as shallow as 8 to 12 feet. It shifts slightly day to day based on wind, cloud, cover, and recent temperatures. The minnow method establishes that depth directly without any instrument. A modern angler without sonar can Follin session volumes, locate the thermocline on any lake faster than rigging a second rod. Once established, structure fishing becomes genuinely useful again, but only as a secondary search within the correct depth band. Find a brush, tolead, or timber edge that intersects the thermocline depth, and you have combined the two location factors that matter. Present at that depth, not 2 feet above, not 2 feet below, and the strike zone narrows from 15 feet of random water column to the band the fish are already holding in. Old bank fishermen, who worked the same lakes across multiple summers, developed a secondary observation that refined the method further. They tracked how crappie behaved in the first hour after sunrise. In early morning, crappie briefly rise toward the surface. This is not a feeding community migration. It is a thermal adjustment. Surface water has cooled overnight. The differential is temporarily reduced, and crappie move upward to exploit prey concentrated near the surface in low light. This window, typically 30 to 60 minutes after first light on calm mornings, is when crappie are found at their shallowest. An angler who finds crappie at 10 feet at 6:30 and assumes that depth holds at 8 o'clock is reading a moving target. Those fish descended as the surface warmed and the thermocline reasserted itself. This descent pattern follows the same warming sequence on the same body of water season after season. The angler who has tracked it knows where to move before the bite dies, rather than waiting for the bite to die and then guessing why. The most common mistake among summer crappie anglers is going deeper in absolute terms without locating the thermocline first. Deeper is directionally correct. It is not a reliable, fixed prescription. A lake with a thermocline at 12 feet rewards the angler presenting at 12 to 13 feet. A lake with a thermocline at 20 feet produces nothing at 12, regardless of the structure there. The second mistake is assuming the thermocline is fixed for the season. Sustained wind can temporarily disrupt stratification, mixing upper and lower layers for a day or two. A cold front dropping overnight temperatures sharply can push the thermocline deeper and expand the productive zone temporarily. These disruptions are brief and follow recognizable patterns. Old bank fishermen, who worked consistent water over many years, learned to anticipate them, returning to the established thermocline depth as stratification restabilized. The minnow method, used at the start of each outing, removes the guesswork. 3 minutes. The productive depth located. No assumption required. What makes the thermocline method useful is not sophistication. It is specificity. Most summer crappie advice moves toward deeper and slower, more weight, slower presentation, darker jig. None of that is wrong. But deeper and slower at the wrong depth catches nothing. At the right depth, the foot or two just above the thermocline, where crappie suspend and feeding efficiency is highest, the same advice produces fish. The old bank fishermen who used a minnow to locate that depth were not doing anything complicated. They were asking a question the water would answer if they paid attention to the minnow rather than the structure. Modern sonar answers the same question faster, but the underlying question has not changed. Crappie do not disappear in summer. The thermocline forms, the fish compress into it, and anglers at the wrong depth conclude the bite is dead. It is not. The window moved. Leave a comment below if this changes where you fish this summer. Subscribe to Traditional Angling, the methods that worked before electronics, explained by the biology that made them work.